Hi everyone, this next video is on tangents and normals. The first thing we're going to do is start off with the gradient of a tangent. So you can use the gradient function or the derivative function, they're the same thing, to determine the exact value of the gradient at any specific point on the curve. So this first example, we're going to find the gradient of the tangent to the function x squared minus 4 over square root of x at a point where x equals 4. So this means if we were to graph this function, where x equals 4, we're drawing a tangent there and we want to find out what is the gradient at that point. Now to do this, we need to find the derivative first of the function because that will give us our gradient function, then sub 4 into that and it will tell us the gradient at that point. And with this question, I'm going to do it two ways. So I'm going to show you how to do it by hand first, and then I'm going to show you how to do it on your calculator because these types of questions can come into either paper. Alright, so first of all, let's find the derivative of the function. So the first thing I'm going to do is rewrite this function without a fraction and a square root, which will be x squared minus 4 x to the power negative a half. Because remember, the square root gives us a power of a half, then we want to take it out the fraction, so then the power becomes negative. Now let's do the derivative of this. So hopefully you did the questions from your booklet, so you're a pro with these types of derivatives. So x squared will be 2x, then minus 4x to the power of negative a half. So we're going to bring the negative a half down, multiply it by negative 4, which will give us plus 2x, and then minus 1 from a half, which will give us a negative 3 on 2, or negative 1.5. Now we've done that, we're going to sub that x equals 4 into the equation, and that will tell us the gradient at that point. So we're going to we want f dash at 4, when x is 4, sub 4 in, so we'll have 2 times 4 plus 2 times 4 to the power of negative 3 on 2. And when you work this out, you will get that it equals 33 on 4. So the gradient of the function when x equals 4 is 33 on 4. So now I'm going to show you how to do it with your calculator. So when you're doing this on your calculator, what you need to do is you need to go to a calculator screen, and then you're going to go to menu, and you're going to go to calculus, and then numerical derivative at a point. So that's basically meaning we're finding the derivative at a given point. Now our variable is x. The value that we're wanting to find the derivative of is where x equals, which is 4, and we're going to look at the first derivative and then press OK. And then from here, we just type in the function that we're trying to find, so our original function. So the x squared minus 4 over the square root of x. And then you just press enter on that, and you get your answer of 33 over 4, just like we did when we did it by hand. Our next step is looking at the tangent and normal to the curve. So the tangent to the curve at any point P is the straight line which passes through P with gradient equal to the gradient of the curve at P. Then the normal to the curve of P is a straight line which passes through P that is perpendicular to the tangent. So you can see in the diagram there, the blue line is the tangent, the green is the normal, and the green and blue lines are at 90 degrees to one another. So to find the equation of the tangent or normal to the curve at a certain point, which we're going to call AB, there's some steps for you to follow. So the first step, calculate B. So if you don't know the y coordinate of your x value, then you need to calculate that first using your original equation. Step 2, find the derivative of the function. Step 3, substitute your A value, the x coordinate, into the derivative, as this will calculate your gradient. Now step 4, you only do this step if you're finding the normal, and that is to find the negative reciprocal of the gradient, because remember, perpendicular lines have the negative reciprocal gradients. And in step 5, find the equation of the tangent using this formula, y minus b equals m bracket x minus a. Now we're going to have a look at an example. So we've got this function, 3x squared minus 2. Find the equation of the tangent at x equals 1. So the first thing we're going to do is step number 1. We need to make sure we have the y coordinate at the x value. So we want the y coordinate at x equals 1. So we're going to sub x into our original equation. Sometimes you may be given the y coordinate, so you can skip this step. So we want f at 1, which will be 3 times 1 squared minus 2, which will be 3 times 1 minus 2, which is just 1. Now step 2, we need to find our derivative. So we want the derivative of 3x squared minus 2. So the derivative of that will be the derivative of 3x squared. So we've got 3 times 2, which is 6. X, because we do 2 minus 1 for the power, which is just 1. And then the minus 2 will just disappear because it's a constant. So step 3, we need to sub in our x value to find the gradient at that point. So we want the derivative at 1, which will be 6 times 1, which is just 6. Now, because we're finding a tangent, we don't need to do step 4. We now just need to sub into our equation of a line. Now, step 4, we need to sub our original point, which is 1, 1, and our gradient into the equation of a line formula, which will mean we'll have y minus the y coordinate, which is 1, equals the gradient, which is 6, multiplied by x minus the x coordinate, which is also 1, and there we have our equation of the tangent. Now example 2, same thing, but this time we're going to find the equation of the normal. So when we're finding the equation of the normal, same steps, we just have the one extra step at the end. I want the equation of the normal when x equals 9. So step 1, we need to find out the y value of the original function at 9. So we want to find out f of 9. So we're going to have 2 times the square root of 9, which will equal 6. So our point that we are going to be looking at is at 9, 6. Step 2, we're going to find the derivative of our function. So the first thing we'll want to do is rewrite this with the square root of x as the power of a half. And then our derivative of that will be 2 times a half, which is 1, x the power of a half minus 1, which is negative a half. If you wanted to here, you could rearrange this back to 1 over the square root of x, which is what x the power of negative a half is. Will become in handy for step 3. So step 3, we want to sub 9 into our derivative. So sub our x coordinate into our derivative function to find the gradient, which should be 1 over the square root of 9, which gives us a third. Because we're finding the normal, we need to find the negative reciprocal of this. So our gradient of the normal will equal negative 3. Now the reason for that is in part 3, we worked out that m equals a third. Now because this is positive, our gradient of the normal will be negative. You switch the signs and then you flip the fraction. So 1 over a third becomes 3 over 1, which is just 3. And our final step is to put our point of 9, 6 and our gradient of negative 3 into our equation of our line formula. So we'll have y minus the y coordinate, which is 6, equals the gradient, negative 3, multiplied by x minus the x coordinate, which is 9. And there we have our equation of the normal. So that's it for this video, which means you actually can do the whole of booklet 2 now, including the composite function review that is at the bottom of the booklet, because that will help you with the next bit of derivative content we'll be doing, which is the chain rule. So you are able to go and do the whole of booklet 2. Remember, email me if you have any questions.